the expansion of the steam to improve its thermodynamic efficiency. When the high-energy steam passes through a series of rotor blades, the pressure difference across the blades induces a resultant force in an upwards direction, thus making the blade rotate. Steam turbines are widely used in power generation industries. The high-pressure steam turbine, or HP turbine, is a pressure-velocity compounded, single-axial flow, non-condensing impulse turbine. It is the first stage turbine that receives the main steam directly from the boiler. The intermediate pressure steam turbine is a single-axial flow turbine. It is located between the high-pressure and low-pressure steam turbines. The reheated steam from the exhaust of the high-pressure steam turbine drives the intermediate pressure steam turbine, or IP turbine. The exhaust from an HP turbine, called cold reheat steam, or CRH, the low-pressure steam turbine is a pressure-compounded, either single or dual-axial flow, condensing reaction turbine. It is located next to the intermediate pressure steam turbine and receives exhaust steam from it. It is specially designed to extract work from the low-pressure steam. The function of the governing system is to maintain the speed of the turbine. In India, the governing systems try to maintain a speed of 3000 RPM to maintain a grid frequency of 50 Hz. When the turbine blades are designed to produce maximum rotational energy, the stationary blades are a part of the casing, and their function is to direct the steam coming from the first moving row to the next moving row without any appreciable change in velocity. To maintain a constant turbine speed, the governing system uses steam control valves. If the turbine rotation speed tends to go higher, the control valve automatically reduces the steam flow rate to the turbine and vice versa. A steam turbine lies at the heart of the power plant and is specially designed to extract thermal energy from pressurized steam, which is provided by a boiler. It uses the steam to perform mechanical work on a rotating shaft. The turbine has stationary blades on the casing and rotating blades on the shaft. The rotating blades rotate the shaft when steam blows past them. It further consists of a number of different sets of blades or stages, each helping to extract more energy from the steam before it gets exhausted. The function of the governing system is to maintain the speed of the turbine. In India, the governing systems try to maintain a speed of 3000 RPM in order to maintain a grid frequency of 50 Hz. When the load or the demand on the grid exceeds the supply to the grid, the frequency tends to go below 50 Hz and the speed below 3000 RPM. Similarly, when the load or the demand on the grid is less than the supply to the grid, the frequency tends to go above 50 Hz and the speed above 3000 RPM. It is the function of the governing system to maintain the frequency at 50 Hz and the speed at 3000 RPM in a free governing mode operation, that is FGMO. High-capacity power plants use various stages of steam turbines, such as low-pressure steam turbines, intermediate-pressure steam turbines, and high-pressure steam turbines. A high-pressure steam turbine, or HP turbine, is the first turbine that receives the main steam directly from the boiler. It is specially designed to extract work out of the very high-pressure steam. The reheated steam from the exhaust of the high-pressure steam turbine drives the intermediate pressure steam turbine, or IP turbine. The exhaust from the HP turbine, called cold reheat steam, or CRH, is sent back to the boiler reheaters. This CRH returns to the IP turbine as hot reheat steam, or HRH. The IP turbine is specially designed to extract work from the intermediate pressure steam. A low-pressure steam turbine is located next to the intermediate pressure steam turbine and receives exhaust steam from it. It is specially designed to extract work from the low-pressure steam. All these stages are mounted on a single rotating shaft, which further rotates the electrical generator coupled with it. The efficiency of a steam turbine depends mostly on the design of the blades. The blade has an airfoil shape that creates a rotary force to rotate the turbine when the high-energy steam passes through it. Here you can see how long the last stage turbine blades are as compared to the first stage blades. The tip of these blades will have a very high velocity as compared to the velocity at the root. The steam enters on one side of the turbine through nozzles and leaves from the other side of the rotor. The temperature of the steam drops down as it flows along the blades. To increase the efficiency of the power plant, more heat is added after the HP turbine. After this, the steam is sent back to the boiler for reheating, which again increases the temperature of the steam. The reheated steam is then supplied to the IP turbine. The exhaust steam from the IP turbine further drives the LP turbine. The shaft is coupled with an electrical generator, which uses this rotatory mechanical energy to generate electricity. In some of the intermediate stages of the turbine, an amount of steam is extracted for heat transfer in regenerative heaters. This steam is called extraction or bleed steam. This is done to improve the overall Rankine cycle efficiency of the power plant. The thrust bearing absorbs the residual thrust produced due to the steam flow in the turbine steam path. The thrust bearing serves to maintain the axial clearances in the steam path, and the same is monitored by axial shift probes, which give alarm and trip values. To maintain a constant turbine speed, the governing system uses steam control valves. If the turbine rotation speed tends to go higher, the control valves automatically reduce the steam flow rate to the turbine and vice versa. The shape and construction of a turbine casing depends on whether it is a low-pressure, intermediate pressure, or high-pressure turbine. The turbine casing is made very heavy so that it can withstand high temperature and pressure. For low and intermediate inlet steam pressure, a single shell casing is used. For high inlet pressure, a double casing is used.